So you've all managed to install a package now. So this is how you'll install packages. Now the next thing would be to load such a package. So you can try and tick these type of things. So on the right hand side, if we go back to our studio, these are all packages. And so suppose I wanted to load a bind or ace pack, I can click it, and then you'll see that at the bottom thing, it will print library a bind, or that means now it's loaded and available to R. So 90% of your things are of mistakes are where you think R has the package available, but it actually doesn't have it available. So you forgot to load a package. So what we're going to try and do now is you can try and load your package from within this chunk. So you can try and write library and then ggplot2, and if we click that, then it should load ggplot2. Yeah. So in that chunk, that's how you go about printing packages. Sometimes it will print some warnings, and I'll come to that in a bit. Okay. So R is a basic language. You can do some basic computation, but most of the time I'll be giving you examples of packages, which will then do the analysis for us. Yeah. And you can see here, in those R chunks, you can use a hashtag, not for using a header, but you can write hashtag loading ggplot2. So it's good practice to annotate your code to say what you're doing at every step. So you could do that outside of the R ticks, like outside of those 3 ticks. In Markdown, you could say this is where I load the package, yada yada yada. But you could also use a hashtag to annotate a specific chunk of code. Yeah. So things behind the hashtag are recognized as text and not as code. Yeah. So I'm not gonna tell you too much about this, but this would be mostly if you're on your own machine, or if you have to do work on a server of some sort. So in RStudio, most of your load objects are in the environment, and the environment is in this top right corner. So you have the environment here. You could see from my work, there's all sorts of other things in like called data and all these other things. So that's where stuff lives. Yeah. So if you make a variable or something which is alive, that's where it goes. So you can use the command line to say ls to list all the objects in that space. You can remove objects from that space. You can remove all the objects from that space, and you can save a copy of everything that is living in that environment. Yeah. Most of the time you won't need that, but I have to tell you about it as well. And R stores data as .r data. So, and if you wanted to, you could save an image, and you could use load.r data, and then it will reload all the things that was living in your environment. And history, so you could, if you use history, it will tell you what the commands were that you tried to do last time. Yeah, so it should give you library ggplot2 and then sys.date and all these other things. And load history gives you the load of the command history. So R is a basic calculator, and we can use the semicolon to do multiple operations. So 2 plus 3, 5 times 7, 3 minus 5, and it will give you the answers, hopefully. Correct? Yeah, so within that chunk, you could replace it, and it will be like a simple calculator. You remember mathematical functions? It's algebra in high school, so remember this is a natural logarithm, and that should be 1. If we take the exponential of 1, then we should get that number. Yeah. You also remember the 10 log. Yeah, the log with base 10. And that's how it works. Yeah, so it's a basic calculator thing within those ticks. You can round numbers in R, so we can round to the next integer. It's straightforward with using floor and ceiling. So if we do that, we're going to get 6, 7, minus 7, minus 6. Yeah, so it's rounding it to the next integer by using floor and ceiling. We can use trunc to cut things behind the decimals. So that's also quite straightforward. So we can do trunc 9.75, and get 9, get minus 9. So that's leaving behind the decimal part. These are all basic operations to tell you, which you might use at one point. Now, there's X amount of other mathematical functions. Like you probably are unlikely to use cosine and sine and tangents, which you remember from your trigonometry. but they all exist in R as well. So if you need to solve things like what is sine times cosine this, R can solve it. So the most common things are printed there. And what I should tell you about is what should also be, you should know from Excel, is the notation of larger numbers. So very large numbers with lots of zeros take lots of space in the computer. So sometimes it will abbreviate 1.3, E3, and E in this case is not the base 2.71, that number, but it basically means move the decimal to the right. Yeah. So that would be 1300. This would be to the left, so -2, and that's just because when printing things to the output window, it will print lots of zeros otherwise. And if you're unfamiliar with that, try to do it in Excel, because Excel uses the same annotation for moving things to the left or to the right with decimals. Yeah. For those of you who remember, again, algebra, you can also do complex numbers and imaginary numbers. So you probably remember that you can't do the square root of -1. That's an imaginary number, and R can also handle those type of complex numbers. Very unlikely that you need it, but I'm just telling you that it exists. So the next thing is to make a variable, and so we often want to store things to use later rather than using the raw numbers. So this is, I must admit, a couple of years ago, so I've aged slightly. So this will store my age as a variable somewhere. It's important to note that they're case sensitive. Yeah. So if I had put Thomas with a capital T, that's not the same as Thomas with a lower t. It's really sensitive to that. You can't have starting things with numbers. You can't have things starting with special symbols like dollar signs or percentages.
Sure, it's just down there.
Okay. And you should not have blank spaces. So I couldn't type Thomas space age. It needs to be connected. So underscores or dots, depending on your preference. So you use body underscore weight or body dot weight rather than body space weight. Yeah. So far with me? These are all very basic things. So I'd like you to pair up in a duo and make a variable for one of the people in your duo with your age. So just sit together with one of, just form a duo with two, or on your own if you feel very confident. And just in that chunk, make something like Thomas underscore age. And then you might have to move around a little bit. Or there might be people who have to form trios because we're odds and evens. So again, you can put that between the three ticks in those in that chunk. And then what should happen is that once you've done that, it should appear in your environment. So the three ticks with R code, where you previously put sys.date or sys.time.
Yeah, on the 19th.
Yes.
Yeah.
And so you could put like a.
So we just delete it and then just put it.
And the arrow needs to go in the opposite direction, as you can see in the example, like it's yeah. Yes. Yeah, the arrow dash or the carrots. I think they call it the carrots. If you press that play button, so you can see it's stored something there like magic in the environment. So later on you can call it out and then use it for calculations or adding things. So all of those through plan, you should have something in your thing. So then you can add, you can say all age times 2 or the next line. Yeah.
So you avoid typing in the console.
You avoid typing in the console because the idea is that you will finally work through this and say this. So you can use the console for shortcuts to sort of see what's happening. So I'll tell a little bit later about the console, but we want people to use mostly the R Markdown thing, press chunks as they go along, and then because that will build it. If it works in the console, it doesn't mean it will work in that.
Nice.
You managed to make a variable with your own age? Yes.
Really?
Everybody sort of managed to make a variable inside of your environment. So there should be something living there. Okay? So, the next bit is slightly boring, but I have to tell you a little bit about all the different types of variables and types of things that exist in R. So, mostly for your reference, but you have integers, which are whole numbers, Yeah, so 15, 23. You have numeric real numbers, like this is a real number. And in computing science, they're known as double precision variables, so they have double precision. You can have text strings, like hello world, Dr. Pollitt, all these other things. We can have logical variables, which are just telling it whether it's true or false. Yeah. And we can also have object classes. So these were object modes, if I'm not mistaken, and these are object classes. So you made it a very basic vector, so just a variable with one thing. So we can have something which has discrete groups, like a factor variable, like education, like high school, no high school, university, postgraduate. We can have a matrix. A matrix is basically has 2 dimensions. Yeah. So most of the time when you're working in spreadsheets, they are matrices. You have rows and columns. Yeah. But we can also have, this blows your mind as well, you could have a matrix with n by n dimensions. That's known as an array. You have also something special which is called lists. So a list can be a list of matrices, it can be a list of vectors. So you can store things in the list and then call things from a list. And you can have a data frame, and this is the thing you care about most. And this is like a matrix, but it has some additional information on rows and columns. Yeah? And so that's most of the time you don't have to worry about those type of things, unless you get to really advanced stuff. But most of the thing is data frames. Yeah? And so many of the errors which R will tell you is because it's expecting, let's say, a matrix, and you're giving it a data frame, or it's expecting a list, and you're giving it a vector. And so that's where most of the errors come from in terms of programming. So it's expecting one type of input, and you're feeding it something else. So assignment, or how to label the vector. So you've done that. So we use this. You could also use the is to do the same thing, but like Carol H, or like anybody's H and is. I would recommend you use this assign operator, because is also a mathematical operator, and it might lead to some issues. So suppose we want to combine things. We can use the C thing to combine vectors and to combine things. So C just stands for combine or concatenate. We can have sequence X to generate a sequence of things. And I'll give you some examples in things. And these square brackets denote an element. So unlike Markdown, this tells you an element in a vector or in a matrix or in something else. So lots of things to digest. Some examples. So we can print a sequence like this. So sequence 1, 2, 5 will print as 1, 2, 3, 4, 5. Yeah. We can make something which makes my height. And if you were to then in the next step just have that, so this won't print it, but this will print the actual value to your output. So then it should print what it's saying. I can make, so that was just one number. I can make something by combining different things. So with something which has 7 elements, which is the number of coffee breaks which I take throughout the week. So let's say I take 1 on Monday and 5 on Sunday. I'm just going to close this door because it's quite noisy. That's okay. Okay, so you could make something with 7 elements, and that's the number of coffee breaks I have in the week. And so it's nothing more than combining all these numbers. And then it will print that if we ask it to print it. Very basic so far. Everybody still with me? We can. You notice that there it prints the elements. If we just want to know how many elements there are in this vector, we use length, and that should give us 7, because there are 7 elements to it. Yeah. Now we can do the days of the week. We can do Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We can get it like that. We can ask it to print the 5th element by using the square brackets. Yeah. So just using the square brackets should print Friday, and it does. Now, if we wanted to print elements 1, 2, and 3, we can use the concatenate command to combine it into 1, 2, 3. So that will print Monday, Tuesday, Wednesday. Yeah, everybody still with me? And then we can also start replacing things. So suppose that we want to replace Friday with Fry, we could simply do that. So this is calling the 5th element and saying, with quotation marks, this is what it should be. And then if we print it again, we can see that it no longer says Friday, but it says Fry rather than Friday. If we wanted to replace things, we could, for example, replace Saturday and Sunday with party time. We use rep to replicate something twice. So this will replicate party time twice. And then what should happen is that those 6 and 7 elements are replaced with party time. Yeah. So very basic programming commands on vectors. So now you're going to try it yourself. I would like you to use hashtag to annotate your code. Make an atomic vector with your height. If you don't know your height in centimeters, have a guess. Make a vector for the months of the year. So that should have 12 elements, like the one I did. Print the 6th and 9th month, and then replace July and August with vacation in your vector. So all the different steps, all the things I've just done and shown you, it's just those type of things. So go back over the slides. So we're going to have to use the C command to combine things. So we like you to make vector with your height, vector with months of the year, or print the 6th and the 9th month to the screen, and replace July and August with vacation. Go.